It's been pushed into the 40s.
There's a patent called ice nucleation for weather modification. This is a patent from NASA. It can be found online in its full form. This patent is for the creation of artificial snowstorms from what would have been rainstorms. However preposterous this sounds to people, if they look up Chinese create snowstorms, they will find a long list of articles where the Chinese Bureau of Weather Modification openly admitted that they were creating snowstorms until they did $1 billion worth of damage in Beijing. So my question would be, if the Chinese can do this, and NASA has a patent for the same purpose, why would we believe snow events here are natural when it's snowing now regularly at 45 degrees, sometimes 50 degrees, heavy, wet, concrete snow that's full of aluminum, full of barium, full of strontium? Consider the ice pack in their first aid kit that can sit dormant at room temperature for decades until the chemicals are mixed together, at which time it creates ice.
As an on-air meteorologist, I had a responsibility to my audience. There were storms that were not behaving as they were modeled or they historically would have responded.
If you can control where moisture is collected and where it's dropped, so to speak, in the form of rain or any other kind of precipitation, then you can really, you can do everything. You can steer the weather system. If you want to be able to manipulate the weather, one of the things we know about the materials that are being used in the aerosols, we've seen everything from aluminum oxide, barium salts, strontium, copper sulfate, potassium iodide, a number of different kinds of things, each of which have different levels of reactivity with the moisture in the air. Some like aluminum oxide tends to sequester the moisture. The aluminum oxide nanoparticles, which are microscopically fine and uniform in size, attract the humidity, the moisture in the air, and it basically forms like a nucleation process where the moisture condenses on these particles.
With cloud seeding, the cooling will be achieved by making clouds reflect a bit more sunlight back to space than they would otherwise, and less sunlight reaching the surface would tend to cool the planet. These aerosol particles act as something called cloud condensation nuclei, and these are sites where these particles act as sites where cloud drops can form.
Well, the one thing that we know has happened is because these are nanoparticles and they float like mad with a little bit of moisture added to them, they go over the Continental Divide and they dump all of California's rain into the Mississippi Valley, which is the reason they're having floods and tornadoes and fierce storms and odd weather back east. The effect here in California is drought.
Now then, if you hit that area of the sky with a beam of a particular kind of radiation, and you can heat those particles up, just like heating up, your cup of coffee in the microwave, these particles begin to vibrate and resonate if you use the right frequency of RF energy, that they then heat the surrounding air, and they will take all of that air and the moisture that's in it to a higher altitude where it's much colder, and it'll condense and then become a low pressure system.
Well, there's a couple of locations where they tend to be very interested in leaving their trails. The big one and the surprising one for me is under areas of high pressure, where you would expect to see the blue skies, the dry conditions. Those are prime targets for trailing. A couple of reasons. High pressure is stable. It's relatively still. We've got the clockwise flow around it. And if you accentuate the high, and so it's very easy to add those particulates of aluminum, barium, and whatever else they want to put in there. And as you add heat to that, those particulates then radiate the heat into the atmosphere and it warms. What does a warming atmosphere do? Boom, it expands. So that's one way. It's a very simple way, but it's very apparent because under the high pressure, it's supposed to be quiet. It's supposed to be still. It's supposed to be blue, and we're not seeing that. Then as the storm approaches, the high begins to recede, and then they're running the flights back and forth, back and forth, back and forth, and literally seeding the leading edges of the cirrus. So the cirrus canopy is accentuated. That cirrus canopy, which would maybe be 200-300 miles out ahead of a cold front, is now 450 miles.
Based on geoengineering data it would appear the Pacific Northwest gets an excessive amount of the fallout from these programs because much of the weather, much of the precipitation and the storm tracks and the jet stream move across us. So as stated by globally recognized geoengineers like David Keith, that's the type of area they would want to seed these particulates as incoming fronts start to cover landfall. And that's exactly what we see here. When there's any kind of incoming front, we see jets everywhere.
The global studies indicate there will be some impact on precipitation patterns, and obviously there's a lot more opportunity for work in that area.
After studying my time-lapse surveillance, one of the reasons I discovered for the trails was that the persistent ones would break, they would misshapen or deform, and other planes would come along and precisely mark off those locations of deformation. And you're not going to get that with a regular fleet, so this had to be one of the primary purposes for chemtrails, in my opinion, was to measure off where we have these discontinuities showing up in the atmosphere. And in doing these actions and discovering those zones where there's different energies in the atmosphere, I think that plays very closely into their weather engineering programs of mark, surveil, and then that data goes into a weather model that they can then use to forecast or, once again, engineer the weather to their designs.
But you can also influence what happens locally with the atmosphere by painting the materials that these aerosols are made of with different kinds of radio frequency or RF energy, radar, microwave, the HARP system.
You know, HARP is an array, a field of antennas, radio frequency antennas. They're 72 feet tall, and they have a cross dipole across the top that's about 60 feet in each direction. 180 of these are in the array today, so you can imagine this field of antennas. What happens is by firing each one, they produce radio frequency energy that normally comes off of an antenna, spreads out rather rapidly. Same principle. Principles in physics would be like a flashlight shining on a wall. You know, you start with a narrow beam, and by the time you hit the wall, you've got a wide beam. The idea with HARP is to get it to focus or concentrate that radio frequency energy so it doesn't spread out, so you can hold it tighter together and then manipulate it in very specific ways. Weather control is a broad topic, so there's lots of ways to control and manipulate weather. HARP is one of them, because you also have private sector companies getting into this business of weather modification. In the case of HARP, do you need, people always ask me, do you need particulates dispersed in the atmosphere to make more effective? You actually don't. Would it make things more possible? Could you enhance certain effects? Probably so. Could you control energy distributions more efficiently? Probably so, because you're putting in conductors, or you're putting in reflectors, you're putting in particulate material.
If you've ever experienced a hailstorm and you've picked up one of the hailstones and you slice it open with a razor blade, you'll see that it's layer upon layer upon layer of ice. Now, hail is usually formed where you have a low pressure system where there's a tremendous updraft of air. When the air gets warmed up by the sunlight ahead of the storm, the air rises, it takes the moisture that's in the air up to a higher altitude where it's much colder. The moisture begins to condense into water droplets, but the updraft is so powerful that the water is carried to extreme altitudes where it freezes. And it begins to fall, and as it falls, it starts to be caught up in the updraft again, so it's circulated up into the air again, and so each time it's lofted up into the atmosphere, more of the moisture that is condensing on the outside of this nuclei of ice begins to form another layer, and each time it's caught back in the updraft, it goes up again and it gets another layer of ice. And so if you have a system like HARP working in conjunction with aerosols, chemtrails that are spraying in the air, you can actually create updrafts that are so powerful that you can have these hailstone circulation patterns going over and over again, where you get hailstones the size of baseballs or even softballs.
Weather has always been a strategic desire to control by the generals, whether it was Napoleon marching towards Moscow, or Hitler in his Russian campaign, or our own Pacific Fleet trying to understand typhoons and use them for our strategic advantage. War and weather are very closely connected, and they've been connected ever since about 1812 or so, maybe earlier than that. Hannibal had to face the snows in the Alps. And so there's a long history of weather and warfare interactions.
Environmental manipulation is like the ultimate method of covert warfare, because you can literally shut down food production. You can create a situation where the people within a country revolt against their own government, and you're invited in to mop up the mess. The issue of owning the weather by 2025, which is a military publication, we've quoted it as far back as I think 94, 95 even. But you go back to these earlier reports and you look at sort of what was the objective, and the objective is exactly that: control the battlefield environment. Environmental factors give you an absolute advantage. If you can weaken your adversary before you have to fire the first bullet, maybe you even win the war.
Whether it's incredibly historic sandstorms when we're invading Iraq, or you want to drought out or flood out a dictator that you're not happy with, or obscure a beach when there's a landing, or if you just want to make money on the futures market.
Owning the weather by 2025, using the weather as a force multiplier. And this kind of goes back to what I was saying before about if you can control where a weather system goes and how much or how severe the weather system is, then you can do other things like you may have heard more recently that many of the aircraft that we've been developing are what they call all-weather capable, which means that they can fly in any kind of weather. They can shoot and target the enemy under really nasty weather circumstances. And these are all things that you can use to your advantage if you happen to be controlling the weather also, because you can have a terrible storm front come in and make it difficult, if not impossible, for the enemy to operate on the ground or to fly their aircraft if they don't have aircraft that are as sophisticated as the ones that you have. And so by creating or using the weather as a force multiplier, as the title implies, that you can achieve an advantage over an enemy force that gives you the upper hand.
One of the ideals of the Air Force is to have this all-weather Air Force, or to have their pilots coming back safely and using the weather as a salient against the enemy and clearing out their own airports from, say, from ice fogs or from bad weather. And so if the idea here is that if we can fly and they can't, that's a great military advantage. There was also research studies on hurricanes that the scientists were truly curious about the behavior of hurricanes, but their military patrons were very interested in how to steer them or direct them in certain ways, almost as a guided weapon.
This jet stream that's moving across, and it shoots 50 miles north and then 75 miles east and then drops back south again and then kind of goes on its way. And they attributed that little dog leg in the jet stream in Alaska to swinging storm systems out of central Texas into central Florida, where they deposited a couple of tornadoes in the middle of Orlando that were like really rare to see in that part of the country. And so people remember that event and they remember that situation. But it'd be a good example of a very small change in Alaska in terms of a jet stream and what kind of a lower 48 effect that would have. And that's again where weather modification, small input in one place can have tremendous change and unexpected outcome in another.
You can create weather systems that are so severe they culminate in battlefield denial, where the enemy is not able to use the roads or the bridges or get through the environment because the weather is so severe. And you can use the weather to destroy his crops, deny him a food source, destabilize his population because people get hungry. When they're hungry, they get angry and nasty and they don't like what's happening. So there's lots of different things that you can do with the materials. It's all how you use them in the environment, how you apply it.